In this example, we have a sales price per unit of $45, variable cost per unit $27, and total fixed cost per year of $300,000. The first question asked us to compute the contribution margin ratio and the dollar sales volume required to break even. First, let's calculate the contribution margin per unit. So contribution margin per unit equals sales price minus variable cost. So $45 minus $27. And the contribution margin ratio is the contribution margin per unit divided by the sales price, or 40%. Now to determine what our dollar sales volume required to break even is we take our fixed cost per year of 300,000 divided by our contribution margin ratio of 40%. That tells us we need 755,000 in sales revenues to break even. We can also calculate the number of units we need to break even. So in order to calculate the number of units we need to break even, we take fixed cost per year divided by our contribution margin per unit, 18. What we get is 16,666.67 units to break even. We want to round up to the next whole unit because we can't sell a partial unit. So in break-even analysis, we round up anytime there's a number past the decimal point, and it doesn't matter what number that is. It could have been 0.067, and we still would have rounded up to the next whole number because we can't sell a partial unit, and anything yet less than the whole unit would operate at a loss and not a break-even. The second question is, assuming the company sells 20,000 units, compute the margin of safety in dollars. So remember, our margin of safety is the difference between our projected sales revenues and our sales revenues to break even. So our sales revenues at 20,000 units is 20,000 times our sales price of $45 per unit. Or $90,000. Our sales revenues at break even is 750,000. So our margin of safety equals 900,000 minus 750,000, $150,000. Our next example looks at what happens when we do CVP analysis with more than one product line. So we've been looking at examples where we only sell one product. Now we're going to look at an example where we sell 3 products. So when we use 3 products, we can use their sales mix percentage to create an average contribution margin across the sales mix. So we have information about the 3 products that we sell: vests, skis, and ropes. We have selling price, the variable cost, and what our percentage of sales mix is. So first, we're going to look at what is our unit contribution margin for each item. So we have our sales prices and our variable costs from the table above. And remember, unit contribution margin is selling price minus the variable cost. So we're given our unit contribution margin for all three products. Then we need to determine the contribution margin ratio for each project. Contribution margin ratio is contribution margin divided by the selling price. So our contribution margin that we just calculated divided by the selling price. We then take that contribution margin. So the contribution margin for vests is 50%, for skis is 30%, and for ropes is 80%. And we take that times our sales mix percentage. So we have our sales mix percentage for vest is 20%, for skis is 70%, and for ropes is 10%. So we take our contribution margin per unit times our percentage of sales mix. We take that for all three items and we add them together to get an average contribution margin for the sales bundle. So we get an average contribution margin ratio of 39% for this sales bundle of three products. We then take our fixed cost of $714,000 or $741,000. So our break even or our sales is fixed costs divided by our contribution margin ratio, or $1.9 million. The second question says, what is the total annual sales the company must generate to earn operating income of $234,000? When we're looking at trying to calculate a particular operating income, we then want to add that operating income to our fixed costs. So we would take $741,000 in fixed costs plus that operating income of $234,000 and then divide that by our average contribution margin ratio. That gives us a total of $2.5 million in sales to generate an operating income of $234,000. The third question asks, what marketing strategy would you pursue to help the company maximize profit? If we're trying to make profit, we want to market our products with higher contribution margins over our products with lower contribution margins. When we come up and see our current product mix, we see that skis are 70% of our total sales. However, vests and ropes have much higher contribution margins to our bottom line than skis do. By marketing and increasing the sales of vests and ropes, we can increase our sales just by looking at that contribution margin benefit. So if we were the marketing manager, we would focus on selling vests and ropes over the number of skis that we sell. The next thing that Chapter 20 talks about is mixed costs. So we're going to look at this example of how to calculate what the mixed costs are. So we want to look at the variable and fixed costs. We're trying to predict that when what we have is the total amount and whatever our overhead base was. We're going to use what is called the high-low method. So when we're using the high-low method, we look at the change in cost divided by the change in the base, or the change in the volume level. We want to take the highest cost minus the lowest cost and divide by the highest activity minus the lowest activity. This gives us our cost equation. The cost equation is the same equation as the equation of a line, if you remember that from math class. Y equals mx plus b. In the cost equation, y is total cost, m is variable cost, x is the number of our units, in this case direct labor hours, and b is the total fixed cost. So when we're looking at a high-low, we want to look at what is the highest month versus which is the lowest month. We can see the highest month is January and the lowest month is April. So we want to take 975,000 minus 70,000 for our change in costs. We can put parentheses around these. And we want to divide that by the change in our base. So the highest amount minus the lowest amount. This gives us a number of 40. 40 is our M in this equation. So our variable overhead cost is $40 per direct labor hour. To calculate then what our total fixed cost is, we're solving for B here, we're going to create that equation of a line. So we take one of our points, we take the April amount here. So 700,000 equals $40 per unit times 12,375 direct labor hours plus our B, our mixed cost. That's what we're trying to solve for. So we're going to take 700,000 equals we're going to take 40 times 12,375 plus B. Don't want an equal sign there. Excel is fighting me today. It really wants to put that equal sign in there. So then to get B by itself, we're just doing simple algebra here. So we take 495,000, we subtract that from both sides to get the B alone. So our fixed costs equal 700,000 minus 495,000, or $205,000. The next question then is, what is our total overhead costs for this 3-month period of June through August if we have 40,000 in direct labor hours? Well, we now have an equation of $40 times the number of direct labor hours plus $205,000 equals total cost. So we want to calculate that. We're going to take 40,000 times 40, let's put parentheses, plus our fixed cost, 205,000. So remember, this is 205,000 per month, and we're trying to calculate for 3 months. So we need to take that number times 3. This gives us total cost for this 3-month period of $2,215,000.